Welcome to this introduction to Python in our Advanced Analytics in Healthcare course. This is our first module. We will go through a couple, but I want to start with the why it matters. Why should I be thinking about Python? Why should I consider it as a skill that I should pick up? The learning objectives today are just to define Python and understand it, recognize a bit of its benefits and where it fits in the work tool ecosystem for healthcare analytics. And then we'll look at some of the capabilities and understand a little bit of the boundaries of what we'll talk about in this class. A bit of the why, number one, we just continue to grow tons and tons of data in healthcare, and it's not going to slow down. We are monitoring more than ever. We are keeping more data than ever, and it becomes an absolute impossibility to process this all with Excel or with traditional tools. And so we need something a little bit different. Python is a little bit different. Python is a programming language, and some of its advantages, some of the reasons I think it continues to grow, are simple things, human things. It's readable. They talk about it as a high-level language, just meaning that it is not working at a really, really low level on the technical pieces of the computer, but it's a high-level abstraction that humans can read the syntax. That's relatively intuitive. You can read and understand this code by just reading through it like a sentence sometimes. It's perfect for beginners, but also pretty equipped even as you advance into the skill set. It's very versatile. It has a lot of different purposes. Folks have built libraries around it to make a ton of different modes of working possible here. So you can do everything from web development, analytics, automation of tasks, predictive AI, machine learning, and beyond, and bring it all together and publish it out, deploy applications. All sorts of things can happen through this one language. So that versatility lends to bigger and bigger possibilities, right? It's got these great building blocks that can come together to make it extremely capable. And the last thing that's really made it have the ability to grow and expand is its open community. So it's an open source software, meaning it's free to everybody, and it's this giant program of people developing it to become even better as time continues. And so that openness is a great aspect because there's a big community around it. The people who have built it have also offered up their expertise in using it. There's also just a giant user community, people who use it regularly and share out what they use and how they use it. The resources are really strong around this language, so you're very rarely stuck, especially when you're a newcomer and getting started. There's a ton of content available online for free to get into this technology. That's the other thing that's really kept the bar low enough to help this technology spread. But why in healthcare? Okay, so first of all, it can be capable at data manipulation, right? Clean, reshape, and merge data with different libraries that it has, Pandas being one of them. But really, why that matters is because this is where some other tools that would traditionally be used start to struggle. So SQL is great at the initial grab and reshaping of data, but once it turns into a multi-step process of merging and reshaping again, manipulating or calculating over the data in multiple steps, that's where SQL falls apart. The language just requires so much volume to create some of this workflow that you're better off moving to something that's built for it, like Python. Then after that is where it really becomes unique and beyond the current kind of tools that people work in, beyond Excel, beyond SQL, beyond these other things. First is that it has the ability to do modeling and prediction, which is more and more an interesting topic people want to be doing. So you can run statistical analyses with the tool. You can also build advanced machine learning models here in Python. After that, its other sort of unique category is this integration and scale. So outside of the ability to process data, there are a ton of libraries set up to help you connect and integrate data and even publish out, all the way to publishing a web application. And so it's this whole other realm that is possible and can really help in the orchestration of data coming together from different sources and out to a custom product if that's the direction that you have to head. So this is where it really differentiates, because SQL does not have the ability to do any of this work. So it's the tool to use when we're doing that kind of thing. But I want to show you some examples so you can understand a little bit with some real world. Why would I have to run there? Why would I run there? How does it look different? Let's start with something that really Excel could still do if our data set is small enough, which is not a given, of course. We're going to start with this basic example where we need to do something like calculate the length of stay with some sort of business rule. Okay, so just like hey, I want to know if our length of stay is less than 4 days, then I want to return that length of stay. Otherwise, give me, I want to return nothing. Otherwise, give me the length of stay. So just some sort of business rule, like, oh, I'm not interested in those less than 4 days. For some reason, in your question, if this is necessary, Excel can process this. You have to get comfortable writing if statements or take multi-step processes through a couple of different columns, or do something very manual in order to remove everybody with less than 4 day length of stay. So Excel is still possible here, but if the data set is too big, can't do it. If you're not used to writing these if statements, can't do it. But it's still possible in this situation. SQL can do this sort of thing too. It has analytical functions in it, and especially for something this straightforward, you would have an opportunity to do this sort of work. So you would use a case statement, very likely, where you're looking at the data, and I've used our hospital encounter table so that you can go ahead and practice this in the demo hospital system data set. But you're going to see that it's 4 lines long. It is a bit complex. It's doing something relatively understandable if you look at it. It's saying when there's this timestamp difference in hours, that's less than 4, then we want to give nothing. Otherwise, we will take a look and return the length of stay rounded, to 1 decimal place, something like that. So it's possible, and it's a little bit cumbersome, especially when you move beyond this type of logic. That's where it starts to get trickier and trickier, and we'll look at an example of that. But with Python, it's built to do things like this. It's built with tools and libraries to make this sort of thing easier. So I've shown both calculating length of stay and then using it with some logical formula. What's going to happen here, as an example, is we're going to just add a column into our data set where we use 2 previous columns, the discharge time and the admit time, and we subtract them with this date library, DT, and we get it down to total seconds times 24 times 3600. So if you were to look at this equation, it sort of makes sense. It's saying in this DF, it just standing for data frame, just sort of a generic data frame, the column named length of stay days should be equal to this equation where we take discharge time minus admit time. And the library here is just helping us apply, the level at which we calculate that. And then the second item there, we apply this business rule. And so next we want to go ahead and take that same column, that length of stay days, and have it equal to something else. So this is, kind of multi-step logic, but we're accomplishing it with this one line. And so what you see in the line of code there is we take that column and we do an apply of this lambda function, and we just create our own function. This could be as complex or long as you need to, and you would get used to understanding this syntax, or you use new tools to help you digest it. You're using ChatGPT or heading to Google to understand this Lambda function. It's doing the same thing as you saw in the previous examples. None if that length of stay is less than 4. Otherwise, we round the value, to 1 decimal place. So that's an example of Python doing it basically in one line, where you could do something in Excel. It's a lot more complex and a lot more moving pieces in that equation. And especially if the data set gets big, you couldn't do it anyway. In SQL, you were looking at 4 lines of code that it is capable there too, but it's cumbersome and can be just sort of complex and not built for that. And that's a base case. So those are your 3 examples, right? Here they are, looking at them together. You've got at the top Excel, which is getting to know this really sort of deeply nested equation with the if statements. SQL, where it is spelled out more directly, but you're doing it line by line and it gets kind of long. Or you can do this all in essentially one line with Python. So let's look at another example of doing something like this. This isn't actually calculating length of stay with business rules. This is something different. I've got a business problem for you. Let's say quality patient safety want to flag encounters that might represent documentation errors. So they're looking for patterns that span across multiple fields or columns. Okay, they're looking for a flag if any of the following are true. We've got patients transferred greater than 6 times within their encounter. Their discharge disposition is expired, but no critical values recorded in the last 8 hours. Length of stay is less than 3 hours, but patient had med-administrations, multiple. Patient moved from ICU to med-surg to ICU within 24 hours. Or the heart rate shows a flat line. So this is 1, 2, 3, 4, 5 specific pieces of logic that we want to apply in order to get a flag that this is true and look for this sort of signal. So this would be a typical type of business problem that a clinical owner would bring you and say, I need to find patients that might have one of these conditions. Now let's look at Excel. I'm going to basically say you can't express this in Excel. You could, but it's going to be multi-sheets, manual filtering, and there's very likely you're still going to miss some of these patterns, or you're going to have to build multiple different types of use of this data so that it will become really hard to trace what it is that you accomplished and what it is that you did. If you're an Excel wizard, I'm sure you're thinking, oh, of course I could do that in Excel. And I'm sure you're right, but it would be long and cumbersome. If you're versed in SQL, I would imagine you can also track a path to this, okay? And so you're seeing on the right an example of how that might happen, where you're going to use some of the analytics functions and stack these together. Maybe you're using CTEs to do multiple different parts of this logic. But basically, when you start moving towards patterns over time, derived measures where you need to aggregate first and then use the output of that to make decisions within the data, or any sequenced patterns where multiple things have to happen sort of in a row. SQL has a path there, but it's long and it's cumbersome. But I hope you're going to see the difference in using something like Python. It is made for this sort of multi-step logic. And so you can see here a function that I've created where you pass in the encounter information, and it's going to go ahead and evaluate each one of these rules individually in order to create not only a flag like a yes, no, but it's going to go ahead and give a list of what of these exceptions happened. So it's going to step through the information and first check and see if the transfer count is greater than that threshold that they set. And if it is, then it's going to add into this list excessive transfers as a string, so we know that this record did have excessive transfers. Next, you're going to see some multi-step logic, and so it's using sort of an if type statement And it's evaluating two things. If encounter disposition is equal to expired and last critical value is none. So it's just the ability to outline each one of these. I won't keep reading them all to you, but the idea here is that it is a language built for logical processing of data. So you're seeing that we are applying step by step multiple pieces of information, and then at the end all you're doing is you're creating a new column in the data set named flags, and what you're going to get in that column is this list of which flags popped up on this encounter. So it's the ability to process logically multiple rules in multiple ways. We got some and logic, we've got some basic true false type things, and then we create our own sort of custom column and apply it to the whole data set. The other thing that isn't, immediately apparent from just looking at this code is that this becomes something you can operate on millions, even billions of records very quickly, instead of in our other tools, which would be far more difficult. And SQL nowadays is done more in the cloud, and so it's less of a barrier, but this is still a very efficient way to process data and apply it to an entire record. So the other capabilities that I want to just point out that Python has is this sort of introductory level, like, hey, what can Python do? If you haven't seen it yet. And we're going to go and do this all in an actual Python workbook or Jupyter notebook, running Python code. So you can see as an example through Colab what this would look like. But it can do some of these things. It can ingest data by pulling in data through a file like CSV or Excel. It can run SQL against a database and return that information into memory and use it. It can also hit REST APIs that are sitting out there that have data for you to call in. So very versatile. You're not stuck to one technology or one type of connector that's already built there. There's libraries for each one of these different types of connectors. So as soon as you start to hear a variety of connectors and or something like the data's in an API, already you should be starting to think about Python. After that, the transformation is really unique. The ability to clean, reshape, and apply multi-step logic to your data is unique in Python and can be codified to be able to, redo that work over and over again. Very capable there. After that, we're out of SQL land. This is the stuff that SQL really can't do anyway. And so we are doing things like modeling. We can do machine learning and different predictive modeling with some libraries like scikit-learn. There's also an ability to automate. Reusable scripts can be created, put together into a sequence of activity that can happen on a schedule instead of just when you're available and at the computer. So another capability that's new outside of some of these other technologies. And then finally, deploying. If you are going as far as pushing your data out to a web application or some other environment, sort of the opposite of ingesting is, sending your data out. This is a unique capability that's also here in Python that's very different from just running SQL, in a traditional IDE or something, or what Excel can do. So these are some of the unique capabilities that are possible and why Python has a unique place, why we start thinking about it once we are advancing our skill set. So in the course and the next couple of classes, we will cover reading and writing data, cleaning and transforming it, and the basic analysis and visualizations. We'll do also some pretty thorough modeling pipeline that we will build and show how that works. But there's an entire world here in Python that we'll never touch. There's even ones that I haven't mentioned it can do, that are just outside of the data world. So it's a very capable technology. Don't get lost. Let's just stick to what kind of matters to us right now in this we covered. We're not going to go all the way to building applications, deep AI research, web mobile development, or custom data pipelines type of stuff. Just so you know, kind of where we're starting to draw the line and see diminishing returns on the other side of that. So we're not going to head into that world. I think it's a more exciting time than ever to look at these technologies because you have a new partner with you all of the time, right? With our new AI capabilities, there's even further reduced friction in these sorts of tools. So number one, it's a readable syntax language. So, by looking through the code, you can intuit what's going on and what's happening. But even beyond that, we now have these AI assistants that can help you actually complete this code. They are extraordinarily capable at producing working code and helping you to work through errors. What used to be just hours of searching Substack and beating your head against the wall to learn this sort of stuff is now you've got an expert consultant to look directly at your code, and you can tell it the error you're getting and where you're operating and how you're using it, and get back an expert level answer as to what might be generating this issue for you. You can even ask it for corrected code back that you can just copy and paste in to see if that works. And so you are just limited to your stubbornness to get this done and your capability at using these tools. Outside of that, there's also really supportive communities and tutorials that are available in order to take you further if you're diving in. So I think that the technology is extremely approachable now more than ever, and it's also very, very powerful. It puts into your hands the ability to do some of these next level skills, which is predictive analytics. Some of the most exciting stuff that is happening in advanced analytics. And we're going to get into it. We're going to take a look at some of the notebooks that I've built to demonstrate these capabilities, so you have some sample code to work from, and that's what we're going to get into. Thanks for sticking with me.